Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ. The question is, which one is aromatic in nature? I request everyone to attempt this question in the comment box. Don't worry, after some time you have the right answer with explanation. I believe you have tried, so let's start. Now, which one is aromatic in nature? So question is about the aromaticity. Now, 4 options actually given, more specifically if I say 3 options. So how can I decide a compound will be aromatic or not? Based on a rule named as Huckel rule for aromaticity. What is this rule says? Compound must be cyclic, it should be planar, each atom have at least one p orbital and they are in conjugation, and fourth one is 4n plus 2 number of pi electron result aromaticity, then stability, and 4n pi electron results in anti-aromaticity or instability. So these are the 4 points. By the way, if you want to learn further, you can visit. I've already uploaded a dedicated lecture in my previous YouTube channel. So now question is, which of these molecules following this rule or not? Now let's look at the first one. So first one I've written minus. So this is actually named as cyclopropenium anion. So here student, there is a p orbital. And by the way, there are 2 p orbitals which form this pi bond. So these 3 p orbitals are in conjugation, cyclic, planar, and it is carrying a negative charge. Remember, negative charge means excess of electron. So here 2 pi electrons from here, and at this carbon, it's a carbon ion, means it is also carrying 2 pi electron. So total 4 pi electrons are there. So it means it is anti-aromatic. So it is not our answer. Now if you look at the second option, here 2 pi electron, here also 2 pi electron. So total it also has 4 pi electrons. So this is also anti-aromatic in nature. So you can compare this structure with cyclobutadiene. So that is anti-aromatic molecule. But the problem comes at here. By the way, look at, I have given a pair of electron here, but no negative charge. This carbon is student neutral. I am talking about this carbon. So here there was a lone pair, negative charge. That's why I told this is a carbon ion, but this is neutral. So you can say it is a radical. Okay. And more specifically, if I say it's a singlet radical. Okay. So singlet, you may say actually carbene. Okay, carbene also a radical type in nature, but here it's a singlet carbene. It is not at all radical behavior. It is more specifically a pair of electron like that. What is the actual story? By the way, student, drawing structure is very important. Practice with me and practice in the home. So what is here? There is one p orbital and this is one sp2 hybridized orbital. These 2 electrons are in this sp2 hybridized. So that's why I'll not say technically it's a radical. It is actually more accurately if I say it's a carbene. Second thing, this p orbital is student, it is vacant, and actually it is in conjugation with all these p orbitals here. So total here if I say 2 pi electron, 2 pi electron, 2 pi electron, total 6 pi electron, and this p orbital is vacant, it is in conjugation. So all the 4 rules, cyclic, planar, conjugated, 4n plus 2 number of pi electron satisfied. Here total 6 pi electron, means if I say 4n plus 2, it means n equal to 1. So this carbene is actually aromatic carbene. Now carbenes are generally not stable. They are very reactive species, but since this carbene is an aromatic carbene, that's why it has relatively higher stability, and the 2 electrons in these sp2 hybridized orbitals are relatively stabilized. So actually technically if I say this carbon center is a 6 electron species, it's a sextet, but because of this conjugation, I mean aromaticity, the electron deficiency of this carbon center is reduced to some extent. So this is actually our answer, aromatic. So option C is the right answer. I believe this, you have understand the right thing. Now, if this question appears in your exam, you can clearly understand that, sir, this is not possible, anti-aromatic, this is not possible, but it is or none of this. you are confused. So in this case, just try to remember that, okay, no charge given means it is carbene. Okay, now another question, sir, it's a singlet or triplet? By the way, if I say it's a singlet carbene, then what could be the situation? So this is sp2 hybridized carrying 1 electron, and this p orbital carrying 1 electron. So 1 1. So in this case, it could be considered as diradicals. But student, remember one thing. Compound will prefer to have more stable orientation. I mean, in the previous case, if this carbene gain aromaticity, stabilization, it will prefer to have this. So it will prefer to have aromaticity, means aromatic stabilization, rather than this diradical where it cannot be aromatic, because in this case it will be 7 pi electron. Cyclic planar conjugated 7 pi electron, so it is not at all aromatic. So these will be answer, but it is little confusing. So remember this information such that you can do this problem in the exam hall. So this is the overall discussion. Thanks for watching. If you really enjoy my content, please like, share and subscribe this channel. And please do not get confused about the sign of my channel. It is swastika. It is actually a holy symbol in Hinduism. It is not related to Nazis. I do not support Nazism. That is a very brutal culture. It is actually a holy secret for thousands of years in India. So do not get confused about the sign or logo of my channel. So see you in my next video. Bye bye.